This week I set myself a challenge. Build a deep research agent with one goal. Beat ChatGPT and Claude when it comes to researching YouTube topics for content ideation. Instead of just building a basic agent, I'll be using multi-agent architecture, the same system described in Anthropic's research paper in multi-agent collaboration. I'm going over the ins and outs of a multi-agent system and how I would approach this project, and hopefully teaching you some new and important concepts along the way. Even if you're new to agents, my goal is to spark curiosity, to show you this stuff isn't just for the big research AI labs. So first, before we get started, I'm going to go over what is a multi-agent system. So this comes from Anthropic's research, and they did some very good papers about multi-agent systems. A multi-agent system is a team of AI agents working together to achieve one main goal. Instead of using one complex AI agent, the system breaks down complex tasks into smaller parts. As you can see in this graph, each subagent is given a specific job and tools that it needs to complete the job. Some agents might research, others might write code, and some might analyze data or fact-check results. At the top of the system is the Orchestrator agent. Think of it like the project manager of the task. The lead agent plans the overall approach and decides when it makes sense to bring in the subagents. If the subagent can help it move closer to the main goal, then the lead agent will assign it a task. This approach lets AI solve harder problems, reduce mistakes, and it works more efficiently. By dividing and conquering, it works just like a real team. So here's the plan. You type in a topic like AI agents and the system goes to work. It pulls transcripts, thumbnails from about 20 of the top YouTube videos in that niche. Then it compiles everything into a detailed research report. From there, my agent analyzes what those videos cover and, more importantly, what they don't. It then suggests fresh content angles, script ideas, and even flags knowledge gaps where you could create some unique content. Essentially, it's going to be like having a personal research team that studies YouTube trends, competitors, and audience gaps all automatically. One thing to consider when building multi-agent systems is, do you really need to build a multi-agent system? It's important to keep your software as simple as possible to achieve the final goal. One thing you'd look at mine is this could be a traditional automation flow, but because I plan to build on it in the future, add LinkedIn, X, TikTok, then the chat will blow up. So when a user will ask, hey, I want to research this TikTok, the agent will also automatically assign it to my TikTok agents. Let's go over a high-level view of the agent's plan and the tech stack I used and why I used it. Before we get into all of this stuff about the agent design, I want to go over the framework I used. I ended up going with LangGraph just because I can keep a persistent state across the agents, so every agent has the same state once it's been updated by another one. It acts as like a shared memory across all the agents. One reason I've chosen to do this is I had a problem in testing. When the YouTube extraction bot ran, it started running multiple times. So instead of doing 3 videos, it ended up doing 6, 9, 12, and it wouldn't stop. So I had to add some extra state that tracked the YouTube search count, and then I'd hard code it to stop the agent from hallucinating and ending on a continuous cycle of just calling YouTube, YouTube, YouTube. Think of LangGraph as a tool that lets you design how different AI agents talk to each other, almost like drawing a flowchart for the AI's brain. Each node in the graph represents a different agent or step, like researcher, summarizer, planner, and LangGraph handles the information that flows between them. It's fast to set up, super modular, and perfect for experimenting with complex agent workflows. So in my system, I've gone for an Orchestrator agent that controls the whole system. The Orchestrator agent has access to the create to-do tools. This will create the list of to-dos from the incoming tasks and then pass it to the delegation agent. The delegation agent then takes all the to-do list. It then is responsible for assigning tasks to each subagent that specializes in that area. As you can see, this keeps it simple, and this is the power of a multi-agent system. There's not one agent that's having access to all of these tools, which can cause hallucinations and context overload. Just remember, every tool that's added to a subagent or a main agent eats into the context window. That's why these multi-agent systems are so powerful. You can offload context by passing tools to the subagents. In my system, I've got 5 subagents currently, each responsible for a different task. So I've got the research report agent. This is one of the final agents that I'll probably get called, as it's responsible for creating the structure of the final report. So this is my YouTube research agent, who's responsible for discovering videos, getting all the metadata like transcriptions, views, who made it. The embeddings one I'll talk about in a minute. So this is the missing topic research agent. Its main role is if the final report, they start finding topics that haven't been discussed by YouTubers yet, it'll do some web searches and try and find information and find you some talking points. It's like an extra angle that people haven't talked about yet. You might have noticed I've not talked about a few tools in this list yet. That's because I want to cover an important topic in multi-agent systems. Context engineering. If you just pass huge blocks of context between agents, things get messy fast. Agent starts wasting tokens, losing accuracy, and even hallucinating because they're drowning in information overload. This also adds up onto your bill at the front end. That's why I use something called context engineering, making sure each agent sees only what it needs to see, nothing more. So I needed a way to control context without overloading prompts. My solution was to store context externally using Cloudflare. Instead of passing raw content around each agent, it stores the files in Markdown in Cloudflare. Then, only the file URLs and metadata are stored in my LangGraph state. That means agents pass around lightweight references of the massive payloads I was handling. You think some of the YouTube videos I was pulling was 2 hours long. That's thousands and thousands and thousands of tokens. Subagents fetch whatever context they need now on demand, which keeps tokens usage low and accuracy high. Each subagent has the tool and the ability to fetch the files from Cloudflare whenever they need them. But I came across an issue. When testing my agent that was offloading summaries to Cloudflare in Markdown format, I was still hitting context windows fast, as some of the files were passing transcriptions with 200,000 characters in, which was way too much for me to pull back down. So for the transcriptions, I opted for a different method. I split the transcriptions into chunks and stored them as an embedding on a Postgres database table. This way, when a subagent asks a retrieval question, it pulls only the most relevant pieces of the meaning, not just keywords, keeping the context small and answers accurate. A few really important things to know when building multi-agent systems is each agent will have a name, a prompt, and a description. What I've found is the description is probably one of the most important things about the whole system. You can't have overlapping descriptions, otherwise your lead and task agents will get extremely confused and start assigning tasks to the wrong agents. Or if you have overlapping ones, it will get confused and start calling the wrong ones, or both at the same time. Another thing to consider is to add recursion limits. This will prevent a bunch of LLM nodes spiraling out of control, emptying your bank account and causing endless loops. When creating an agent like this, it helps to create a solid boilerplate base and make it dynamic, and only have a few places where you add subagents and tools. This way you can expand on it and scale it really easily. Giving agents a clean way to access tools and developers to add new ones will help you develop multi-agent systems bigger and faster. So to make all this work, I built a simple tool system in my project. Inside a tools module.ts, I registered all my tools my agents can use, like the file manager, YouTube tool, reporting tool, and more. There's also a main controller called tool registry service, which acts as like a tool dictionary. It tells the agent which tools are available and connects them to the right one when needed. This gave me a reusable way to create tools and subagents dynamically on the fly, giving me massive room for expansion. So in the future, all I need to do is add a new LinkedIn tool, a new TikTok tool, and then I can create a subagent instantly. They expanded my system easily. And because tools are passed around, file URLs instead of full context, agents can stay lightweight and only load extra information when they actually need it. That keeps the whole system fast, efficient, and easy to scale. So let's do a side-by-side test. First, we'll test Claude. I've made a little bit of a prompt, not a massive one, but because it's the research agent, it's got some inbuilt prompting enhancements. So I've basically asked me to create topics around AI agents. So it should create me this full research report with script angles, quotes, common talking points, missing talking points, citations, thumbnail analysis, common styles, recommendations, and examples. So let's see how it does. I reckon it will take about 11 minutes, so we'll probably jump back when it's done. So it's just finished now. They've actually, they've seemed to have speeded it up since they've started using 4.5. It must have took only about 3 or 4 minutes. So we've got the final report here. Looking through, everything kind of looks a little bit generic, because what I think they've done is, they've basically just done a web scrape on blogs, and that's okay, but quite a lot of problems with blogs these days. They're all AI generated, so it's kind of like some AI generation inception going on where we're feeding it more. So this top section's just all generic AI slop that's came from these articles. I think this section's quite good. The notable quotes, it's pulled out some good quotes from some actual real research. I did double check, it does exist. The common talking points, LangChain, which we've actually been talking about, Crew, LangGraph, which we've been talking about, but everything's generic. It's not actually, it is structured in the way I asked, but it is just a lot. It's not that much useful. It's just a load of bullet points. You're still going to have to go on and do quite a lot of research, and it's absolutely massive. So hopefully I can beat this. I hope so. Let's give it a try. I went a bit deep with mine and got a bit carried away and made a landing page and a accounts page, just because I thought if people watch this video, they might want to try it, and maybe it will send people to my actual website for the agency. So let's compare now mine versus Claude and send a research. We'll do the exact same search term. It will bring us to this page. We'll then press research. So as you can see, the research has been initiated. As I mentioned in my system, this is the initial lead agent booting up, and it's creating the to-do list tasks. So now an agent's been spawned up called the YouTube video researcher. It's now going to fetch 20 to 30, depends on how I've set it up in the day, videos of that relevant search term. For each one of those videos, it will then fetch the transcripts and slowly bring them back. As you can see, it's got the thumbnail already. It's loading the video, and the agent's about to fetch the transcripts, which should show shortly. So the first video's transcript's been dropped in. You can now copy it, and now that would have been offloaded as context to the embedding table, which I'll put up a shot of it now being added. The next one's being worked already. It's fetching the transcript. It will show up here. It will then create a super base embedding, and then it will get the third video, because I've only done 3 for the demo for time's sake. And then it will create the final research report, which I'll show you. So now it's at a step where one of the research report agents of sub-agents have been called, and it's analyzing the research data from all of the thumbnails and the transcriptions. And then it will start generating that structure that we asked for, the same sort of research we prompted Claude for. While it's generating the report, I just want to show you how the embeddings are sort of working. As you can see, one of the agents here is pulling out relevant content for the report that it's about to generate. So all of these are the previous embeddings from transcriptions we fetched from the videos above. So now the research agent's done. It's fetched 3 transcripts from that topic AI agents. It's also got the 3 thumbnails, but just to make it clear that it can fetch way more, it can fetch 100 if I wanted to, but just for the demonstration purposes, I kept it to 3 for this demo. I still think I can beat Claude with 3. So as we remember, Claude's was quite generic. There was loads of bullet points. It had random information. It was massive. It wasn't that much use. So I decided to condense it down into a report that's actually useful, and it creates a script from those 3 videos. So as you can see, we've got the AI agent research report. So it gave us 6 different script angles where we can talk about from extracts it's found in that video. So some of the ideas it came up with: AI agents build a simple assistant in 3 steps. Dive, the DNA AI agent reasoning, action, and memory. So it's came up with a little overview of that video you could make, a hook, and some key points that you'd mention. And it even referencing some of the videos that it's seen. So it's gave you quite a lot of videos. I asked it to generate me a full script. So it's gone from the extracts of all the transcripts, and it's pulled out all of these different sections of the script. It even gives a conclusion and a call to action that you might need. It extracts all the key quotes from the different videos, and it even citations them which timestamps they came at and which video they came from. And then finally at the bottom, it's got the 3 videos that it found, and it sort of took reference off. As you can see, it's got base 44 in this video, which was mentioned quite a bit in here. So there you have it. There was my attempt to beat Claude at a research in a specific topic. I think I did pretty well. I've gone a little bit different angle to them, extracting YouTube data and trying to really craft a specific research agent. Although I've created multiple AI agents before, I did learn some things from this project. I need to practice what I preach. What I first set out for and the video I created was way overcomplicated. I created a multi-agent system that was spawning different agents and creating the agents dynamically itself. It wasn't actually solving the issue I needed to in its simplest form. I also started off as a stock agent, and I started doing deep stock agent research, and I didn't have a clear defined problem. This is why 95% of the actual AI agents problems fail, is because people don't set out with a clear problem. So to make AI agents succeed in a business, you really need to define that problem and have it well defined across everyone else and know exactly what the outcome of the agent needs to be. You don't want to fall in that 95% failure statistic bracket, because it will cost you money. Running these agents and experimenting with them is not cheap sometimes. Prompting is so important. People talk about prompt engineering and people just ignore it because they use ChatGPT and Claude and it helps them with it. But when designing agents and creating the descriptions and the tool names, it is so important that they don't overlap. They're really descriptive. The tool descriptions have to be really descriptive, otherwise the agent will not call it or will not know exactly what it does. And you have to think of it from an agent's point of view, not your view. It wouldn't need to be fetch this website. It needs to be this tool is used for fetching websites to get X data from Y. Finally, businesses can really harness the power of deep agents. Imagine having one of these in your full business, where one agent you can query your whole business and generate reports from different sections of the business. Basically, we'll know your full business context and you'll be able to input any questions to it. Because it took a while to build, I thought, let's let people try it. I'll put the link in the description below. It's one free generation and it will grab you 3 videos max, unless you want to pay for it to try it out more. I will think of a better pricing plan, but the reason it's not free is because these are expensive to run. It goes through multiple OpenAI calls. I don't want to go bankrupt from running this agent. If people liked it, I will do a follow-up video where I'll add a LinkedIn, TikTok or other social medias and expand it. But thanks for watching. I hope you enjoyed.